In this video, let us now see how we can carry out binomial expansion. Is that okay? When it becomes necessary to expand a particular problem. This is a question where to expand 2x plus y all raised to power 5. Of course, clearly a is equal to 2x there, and b is equal to what? Y, because this is the general standard. Does that make sense? And you should also take note that this plus can also be minus. It's possible. Alright, n is equal to 5, the power. Now, how do we carry out this expansion here? You see, we really don't need to memorize the binomial expansion formula. It's not really necessary. Is that okay? To memorize it, the binomial expansion formula. Not the general term formula. The general term formula is extremely important to memorize. That's n combination r, a raised to power n minus r, b raised to power r, which is going to give you the nth term of the expansion, which is also equal to r plus 1th term. Is that okay? Fine. That is very, very necessary to memorize that. But the expansion formula, you can work it out without memorizing. All you need to do is to understand this principle. So quickly watch. The first term is always n combination 0. So n here is 5. You have 5 combination 0 times 2x raised to the highest power 5 times y raised to power 0. Are you getting me right? That's the first term. Y raised to power 0 will give you 1. 1 times this term will still maintain this term for you. Move on to the second term plus 5 combination 1 this time around. Then 2x raised to power 4. You notice now that the power of the 2x decreased by 1. Then times y raised to power 1. Take note that here the power of y was 0. At this point, it increased to 1. Again, the third term will be 5 combination 2. Then 2x raised to power 3. You take note that the power of 2x decreased again by 1. Then times y raised to power 2. Here, y is raised to power 1. Here, it increased by 1. So do you see the way the thing is moving, right? As the power of A is decreasing, the power of B will be what? Increasing. They all decrease by 1, increase by what? 1. Decrease by 1, increase by 1. So that is the pattern we follow. Is that okay? That's the pattern. Alright, having said that, you have to move on until the last term is always n combination n, which in this case is 5 combination what? 5. In that case, 2x will have its least power, which is 0. Which will make it 1, such that 1 times this term will remain this term. Then y will have its highest power 5. You want to take note of this, please. At every point in time, if you add the power of a and b, which in this case the power of 2x and the power of y, in each of the expansion, it is going to give you the highest power of the expansion n. For example, look at this point. 2x is power 4, y is power 1. 4 plus 1 will give us 5. Look at this. The power of 2x is 3. The power of 2x is 2. The power of y is 3. 2 plus 3, you still get 5 there. Alright, quickly, let us see how do we evaluate n combination r. Is that okay? For example, 5 combination 0. This is the formula you use. N combination r is equal to n factorial all over n minus r in brackets factorial r factorial. That's the formula. Is that okay? So if I want to evaluate, say, 5 combination 0 now, I'll simply come here. N is 5. So you have 5 factorial all over 5 minus 0. Enclosed in brackets factorial times 0 factorial. Because 5 combination 0, n is 5, r is 0 here. Is that okay? 0 factorial is 1. Take note. 1 factorial is also 1. So if you fix that up here, 5 factorial in the numerator all over 5 minus 0 will give you 5 factorial. This is already 0 factorial, which is 1. So you're going to have 5 factorial over 5 factorial. And you know what the factorial term means. If you give me 5 factorial, it's 5 times 4 times 3 times 2 times 1. You stop. So if I have 5 factorial over 5 factorial, the answer is going to be what? 1. Which is why this 5 combination 0, the first term, the combinatorial coefficient, 5 combination 0 there is 1. Again, if you use this formula for 5 combination 1, substitute it, 5 is n and r is equal to 1 here, you are going to get this combinatorial coefficient 5. If you solve for 5 combination 2, it's going to give you 10, continuously down to this one, which is 5 combination 5, to still give you 1. And then, of course, you can walk through to see how we got this result from here. Let us now look at how we apply the Omak's center-seeking binomial expansion coefficient formula in order to obtain the combinatorial coefficient of any term in your expansion. Is that okay? So the question is, can we actually obtain the value of all these 5 combination 0, 5 combination 1, 5 combination 2 without actually using this combination formula when we are carrying out binomial expansion? Can we? The answer is yes. This formula can help us. Power of a in n minus 1 term times coefficient of n minus 1 term divided by number of terms before the n plus 1 term. Now let me explain this. This n minus 1 is the term before the one whose coefficient you want to get. N plus 1 term is that particular term whose n combination r you want to obtain its value. Then n minus 1 term is the term before the one whose n combination r you want to get. Let us quickly use this and see how this formula can be used. Is that okay? But the first thing you should bear in mind is this. The coefficient n combination 0, that is of the first term, is always 1. In fact, even of the last term, n combination n is also always 1. Which means 5 combination 0 here is 1. That is what I have here. Once I am able to get that value, my problem is solved. And like I said, it's always what? 1. So let us see how we get 5 combination 1 here now. Is that okay? To obtain 5 combination 1, all I need to do is this. Power of a in the term before it. The term before it is this term. A there is 2x. The power is what? 5. So it's going to be 5 times coefficient of n minus 1 term. Its coefficient here, are you following? And the coefficient here is 1, we said. So it's going to be 5 times 1 divided by number of terms before the n plus 1 term. Before this term, you are trying to obtain its n combination r. How many terms do you have before it? Only 1 term. Is that not so? So this is going to be 5 times 1 divided by the number of terms before this one, which is just 1 term. And if you do that, this will give you 5. And that is the 5 we obtained here. Let's try to see how we get the value of 5 combination 2 here. I'm in this third term now, right? Third term. So my n plus 1 is this term. I'll come to this, n minus 1 term. I'll use the power of a, which is 4 here, to multiply the coefficient. The coefficient here is 5. 4 times 5 will give you 20. Then divided by the number of terms before this particular one I am looking for, its n combination r value now. How many terms do we have before this? 2 terms. Is that not so? So it's going to be 20 divided by 2. And 20 divided by 2 give you 10. Therefore, 5 combination 2 will give you 10. You can say that here. So that is how you can apply this formula. In the next video, we're going to pick a value where I will solve an expansion using this Omakar center-secant binomial expansion coefficient, and you'll see it very clearly. Now, let's expand this binomial term on the board here. Is that okay? Let's see how it goes. We're going to use the Omakar center-secant binomial expansion coefficient formula method to obtain the coefficient n combination r. Is that okay? Remember, from here, we're going to have that a is equal to x, b is equal to y over 2, and n, which is the power, is 5. So let us do this and see. X plus y over 2, all in bracket, raised to power 5, is equal to, are you ready? Remember, the first coefficient is always 1. That is n combination 0, which in this case will be 5 combination 0. We're going to get 1. So I'll indicate it. Having indicated it times x raised to the highest power of the expansion, which is 5, it's meant to be times y over 2 raised to power 0. But I'm not going to show that because any term raised to power 0, okay? Is that okay? Which is not 0. Not 0 raised to power 0. But any other number or term raised to power 0 is going to give us 1. Are you following? And 1 times this term will still maintain this term for us. Good. Let's go to the second term. The second term is meant to be 5 combination 1. How will I obtain it? Remember, we're talking about second term now. So it's going to be the power of a here. A is x, the power is 5. So use it to multiply the coefficients of that term. Remember, I want to get the second term now, the n plus 1 term. This will now become n minus 1 term. Are you following, right? So to obtain the coefficient here, it's going to be the power of a in this n minus 1 term. Use that power of a to multiply its coefficient. 5 times 4 will give us 5. Is that not so? Then divide by the number of terms. How many terms you have before this new one you want to obtain. Before this new one I want to obtain, I only have 1 term. Is that also this term here? Only 1 term. So it's meant to be 5 times 1 divided by 1. Therefore, the second coefficient is 5. Are you following, right? 5 times 1 divided by 1 is 5. So it's going to be 5 times x. The power of x will decrease to 4. Then times y over 2 times y over 2. The power of y over 2 will now increase. Remember, it was 0 here, so here it will now become 1. No need of putting the 1 there. We are moving on. The next term now, that is the third term. The third term. So again, the third term I'm about to obtain here is my n plus 1 term now, according to that formula. Is that okay? The Omakar center-secant binomial expansion coefficient formula. So the third term is my n plus 1 term now. So to obtain the coefficient, I'm going to generate it from the n minus 1 term. That is just the term before it, which is this term. Are you following, right? So remember the formula is equal to the power of a in the term before it. Here the power of a is 4 times the coefficient of that term, n minus 1 term. Are you following? So 4 times 5 is going to give us what? 20. Divided by the number of terms before this new one you want to obtain. Before this third term, I already have 2 terms. This one and this one. Is that not so? So 4 times 5, 20 divided by 2, 10. So the next question is 10. Is that okay? It's going to be 10x raised to the power of 10x raised to the power of, yeah, that's 3. Then y over 2 raised to power 2. You notice something? The power of this a decreased from 4 to 3. The power of this b, y over 2, increased by 1 to what? 2. Now, this is just the whole thing about the Omak's center-seeking binomial expansion coefficient. Is that okay? It's a simple one. I want to obtain the fourth term now, the fourth term. So the fourth term will be obtained. Even the coefficient will be obtained from this third term, the term just before it. Power of a. Are you following? Power of a times its coefficient. So 3 times 10 will give us 30. Divided by the number of terms before this new one you want to obtain. This new one, the fourth term, before it I already have 1, 2, 3 terms. So it's going to be 3 times 10 divided by 3. Which of course, 3 times 10 is 30, divided by 3 you get 10. So this term will now be 10. The n combination r value here will be 10. Then x raised to power 2. And then y over 2 raised to power 3. Once again, notice the power of x and y over 2. What is happening there? Alright, let's move on. The second to the last term, I think I'm going to go straight ahead. So it's going to be this power, 2 times 10, which will give you what? 20. And 20 divided by 4 is 5. So we have 5x, then bracket y over 2 raised to power 4. I guess we are now on to the last term now. The last term. How do we now proceed? The same way. The power of a here is 1. So 1 times 5 will give us 5. 5 divided by all this number of times. 5 divided by 5 is going to give us 1. Is that okay? So you have 1 times x. This x is meant to be raised to power 0 already now. Is that also? Because here it is power 1. This will decrease to 0. So no need of putting it. Then y over 2 raised to power 5. So that is the expansion. All you now need to do is to simplify this. Let me see how quick we can work in this. Alright, because it's just the Omak's center-seeking binomial expansion coefficient formula I really want you to get used to here. So let's do the expansion and say this term is x raised to power 5. And then this is going to give us 5 over 2 x raised to power 4 y. Are you following? 5 divided by these 2, then x raised to power 4 times 1. Plus this term is going to give us 10, then coming here times y squared, 2 squared. Remember these 2 squares is going to be 4. Then we're going to get 10 over 4. And 10 over 4 is going to give us 5 over 2. So 5 over 2, x raised to power 3, and then y raised to power 2. That's what this term will be. Okay? Then plus the next one is, let's say, okay, that's this. Once again, repeat the same thing. Open up this bracket, y cubed, 2 cubed. 2 cubed is 8. 10 over 8 will give us 5 over 4. So this is 5 over 4, x raised to power 2 there, and then times y raised to power 3. Alright, so we'll come to this term now. This term will give us 2 raised to power 4 is 16. So that's going to be 5 over 16 times x times y raised to power 4. Then the last term, y raised to power 5 divided by 2 raised to power 5 is 32. Is that okay? 32. So this is going to be plus 1 over 32 y raised to power 5. And this is our solution.